So today we will learn how to write C program, the binary C program for binary search using recursive method. Okay, using recursive method, how to write a C program using binary search. We can implement this program as well using loop structure, that is using while loop, for loop, or do while loop in C. Sound come. But we will now use the different method to implement binary search program, which is based on recursive approach. So first of all, we will go to terminal, and here first I will close the previous terminal and open a fresh one. Then I will go to the folder where I want to store my C program for binary search. So it is C program, and then I will go to binary search, another next folder, binary search. No, I will search in CHING. Okay, now here I will create program for binary search dot will create a program for binary search dot C, the file name, C file name. So first of all, I'm using the stdio.h header file, CLUDE include stdio.h. Next, actually there should be the data, the number. In binary search we use the number among the list of the numbers. We have to find out a particular number. So the list should be, for binary search, the list should be in sorted form. So for this purpose we are taking a list of data that will be searched for that will be used to search for the item, and that will be sorted in ascending order or non-descending order. Okay, so I will say it ascending order because we are not repeating the same data or same number twice, so it should be in ascending order. Now what I am doing here, I will write a program which will find whether a number which the input should be given from the user, whether that number is present in the list. That will check. If the number is present, that means the search is successful. Then then you have to produce a proper message that this number is positioned at this location. Now if it is an unsuccessful search, that means the number which we are trying to get, whether it exists within the list or not, that the number is not present in the list, so that search is unsuccessful. And if it is unsuccessful, then it will display the proper message that the number not present in the list. And also if the number of after once comparison has been done, and if it neither the search is successful or neither the search is unsuccessful, that means we have to continue searching, or we have to go on searching more. So that conditions will be there, which will give you the instruction whether the searching will be continued or not. And so as we are implementing this in recursive approach, that means a function which is doing the searching, and it will call itself every time when the search is when the status is condition is found for searching to be continued more. So I'm just writing it and writing the program, then I will run it on machine. You can use any C compiler to write this program and then run that program. Here I'm using my Ubuntu operating system, where the GCC compiler is built in. So that does not matter which compiler, C compiler you are using, it can be anyone. Okay, so first of all, the list to be sorted in an array, and the array size may be different, but I'm trying the I'm taking an array where the number of elements in this array is 10, but we are not mentioning it 10, but we are using using a constant, and we are storing that value 10 into that constant, and anytime we can change the value of the change the array size just by replacing the previous array size with a new value. So when you are trying to define a constant, the syntax is you have to write hash define, and the constant name is array size, and I am assigning the value 10 for this constant. And as I am using a recursive approach, so every time the function will call itself, and every time that function should get to the array. So every time, instead of passing the array every time for every function, recursive function call, we are declaring it as a global array, so that you don't have to pass the array for each function call. So it is, I'm taking an integer array where only integer data will be stored, and the array name is ARR, and the size, and this is declaring array the way I'm declaring array here. Suppose we will just store 10 numbers, integer numbers in this array, so any arbitrary number I'm providing here. Okay, and the point is that the numbers are in ascending order, because binary search will work only when the array, the list of numbers are in some sorted order. So I'm storing the numbers into that array, 10 numbers, and how many I have, I think 45, then 57, 1, 2, 3, 4, 5, 6, 9, another 1 more, 7, 7. Okay, 10 elements have been stored, and we have declared the array as global. And the recursive function, I will declare it here, which will return void. So void, and the function name is recursion. Recursion, binary search using recursion. I'm giving that function name binary search by recursion. And into this function, what will be the parameter value to be passed? If we know how binary search works, in a previous class we have discussed about it. If you're not gone through that lecture, then I will give that. Then first please see the previous video where I have explained in detail that how binary search algorithm works. So in that case, so I'm providing the search and the items, the list that is to be searched. It's first index of the first number and index of the last number. So lower it will be first number should be lower, index should stored in this variable lower, and for highest value the index is upper, and the num is that number which is to be searched within the list. Okay, now I am writing the main function. Okay, main function. Here I will declare int lower, and also I will assign it value, because initially the array, the first element of the array is at 0th index, so lower value will be 0 and upper value will be the array size -1. So I am assigning the value for upper variable and lower variable. After that I want to get the number which I want to search in this list, and the number should be given input from the user. So I am declaring a variable where the num where the which value to be searched in the list, and then I am using I am giving instruction to the to user to input the value for num which you want to search. So enter number to be searched in the list, so the input should be given by using scanf function, as so it will be, as it is integer, so %d will be format for integer, and the ampersand will be used, and the num is a variable name. So when user inputs a number, then it will call the function binary search by recursion, this function to be called. So I will call this function here, it will do its work. See, the parameter type declaration is not required, only the value of lower, upper and num should be provided, should be passed, and it will do its job, and after that the program will terminate. Okay, now I am saving this. Now I have declared the recursive function binary search by recursion. Now I will define the function body. So void recursion, then the function body, it will at any time either it will return a successful search, or it can be an unsuccessful search, or at a time the decision is to be go for further searching. So what will happen if I know how binary search works between lower and upper? We using that lower and upper value, we will calculate the mid value, which is center value, and the number will be compared with that center value. If that number is less than the center value, then we will go to the first hub, continue searching for the list, the items in the first hub, or if the number is greater than the value of the mid element, then that means that there is a possibility that the number may be in the second half of the list. So based on that, we will declaring a variable need, which is calculated by using the lower and upper, and this is divided by 2. Okay, now if so when suppose, now the question is that if first of all it will check if suppose we will compare the number with mid element. So if num equals to array of mid, if it is matches with the mid element, that means the number has been found. So in that case, we will produce the proper message printf and printf that percentage d number is present at percentage d location, which and it needs number of comparison is how much. So here also I am declaring an integer variable, so it will give you that how many number of comparisons you have done to get the result. Okay, int number of comparisons. Okay, and global means it will be global variable, so it will be initialized with 0 automatically by default. It does how many comparisons? Number of percentage d it does comparisons. Okay, so I have to give the value which is a number, is the num which is present, and which location. So location is mid, and how many comparisons have been done, which is number of comparisons. Means here I will, because if it is first search it matches with the number, then only one comparison is done, and so I am number of comparisons plus from 0. If it is first time comparison, it gets matched, so only one comparison has been done, so our first time incrementing it, then this value will be displayed here, number of comparisons. Okay, and after that the program should return, so that's why I will return, but there then before that, here also I have to write the other possible results for after comparison. So after if then I will write return at last. So else if, that means number has not been matched with the center element, then it will check whether it can belong to the first half or it can belong to the second half. So what is the condition that a number will be in the lower half? So else if, the condition is else if num is less than the middle element, then that means the number will be in the lower half. So num is less than array of mid. So in that case, what I will do, that means then we have to continue searching for the lower half, and for that lower half, lower will be same as the previous value of lower, but upper value will be mid minus 1, because we are now the upper value is reduced, we have to search only the lower half, so the upper value should be modified. So the upper value equals to mid minus 1, and this is one comparisons has been as one comparisons have been, this is also one comparison, so I will do number of comparisons plus, and if after that we have modified the upper value, then we will call the recursive function, that means this binary only it will update either the value of lower or either the value of upper based on which condition it has satisfied. So I will call this function the same function within itself. Okay, so this is condition for searching when to search the lower half. If the condition is not satisfied, then there is a probability that the number will be in the upper half. So what is the condition so that number will be upper half? Is that num is greater than array of mid. If this condition satisfied, then that means we have to continue searching, but the upper value will be same because we will search the higher half. So upper value will be same, but the lower value will be mid plus 1. So we have to update the value of the lower value, update the value of lower variable, which is mid plus 1, because now we will search the upper half. So the list lower index and lower index only will change. And also here I have done one comparisons, so I will do here number of comparisons plus plus, then the search will be continued for the upper half. So we will call this function itself once again, only the lower value will be different in this call. Okay, so it is like that. Now what happens if it does not match, if it does not less, or if it does not greater than, then the only condition is that lower value crosses the upper value index. So when this happens, that means the search is unsuccessful and we will not search on, we will just display the message, so the number is not present in the list, and we will terminate. This unsuccessful search will be written as the first condition. That is, if what is the condition for lower search? That the lower value, every time it is getting modified, lower value is greater than the upper value. Lower value is greater than the upper value, that means the search is unsuccessful, and so that will be first sequentially, that will be checked first. So else if it will be, so any at a time any one of the condition will be satisfied. So if lower is greater than upper, then printf that percentage d is not present in the list, and it needs how many comparison it needs, percentage d comparisons to confirm comparisons. Okay, so what is that here? That num and number of, here I am not checking, I'm not doing the comparison between num and any of the element of the array, so that's why number of comparisons won't be incremented for this condition. So it will be number of comparisons. Okay, and anytime one of the if condition will be satisfied, and after and at last I have to return. So this is the recursive. So I'm saving the file and closing it, trying to run it. You don't have to worry about the way I'm running it, depends upon compiler. GCC out binary search .c error. This is the command to run that C program, binary search. Now it is showing some error, that is void binary search by recursion. So again I have to here the hyphen, it should be underscore. So the error was there. Again going to the screen, what kind of error is there also. Every time it has a, so every hyphen should be replaced by underscore. Similarly, every, now I think here also, so here also I will replace underscore, because in any name function name it does not allow hyphen, only underscore is allowed. So I am saving it, then closing. I'm just clearing the screen. Okay, now I'm running the program. Now it has run quite okay. So now enter number to be searched, and let's suppose 100. So 100 is not present in the list, it needs 4 comparisons. Okay, next I'm doing, suppose again I'm giving some value, suppose 4. 4 number is present at one location, it does 2 comparisons. How many comparisons is required? So up to this, suppose any other number, if I just open, what are the numbers here? Suppose 30. 30 means number of comparisons. How many number of comparisons? So mid value is 1, 4, 7 to 11, and 0, 1, 2, 20. Then 30 is greater than 20, so it will search the upper half, and there will, the next comparison will be with H 9, 8, 7, 6, 7. Let's see the number of comparisons for that. So it does 4 comparisons. It does 4 comparison. How? See, first it will be compared with 20 is as 30 is greater than 20, then it will search the upper half, and here it is 6, 7, 8, 9. So it will be compared with 45, does not match, and it belongs to the list. So 57, 6 and 9 means 15, 7, so it will be there. Now lower half, so 2 comparisons, and then it will be compared with 30. So if it matches, so I think 3 comparisons, but here it is showing 4 comparisons. Why? It should be 3 comparisons, no? So what is the problem here? 0, 1, 2, 3, 4, 5. First comparison will be with 11, because 0 plus 9 by 2, it will be 4, and the number then belongs to the upper half, and within this upper half, the lower value will be 5 and 9 upper value, so 15, that means 7. So 4, 5, 6, 7, it will be compared with 45, then it will search the upper half, and it will be 7, 6, 5. So then it will be first 11, then 45, then this is 9, the 5 and 6, so it will be compared with 20, it does not match, then after 4 comparison it matches with 30. Okay, now thank you. This is a program for total binary search program using recursive method. Okay, so I'm just exiting from this window. Okay, and thank you. Okay.